Hi, today's question is about machines and power. Part A of the question reads, define the term mechanical advantage of a machine. Then the answer is, mechanical advantage is the ratio of load to effort. Just as simple as that. Then part B, the figure below shows a car jack with a lever arm of 0.4 meters and a pitch of 0.005 meters. If the efficiency is 40% and an effort of 25 newtons is exerted on the lever, then Roman 1, determine the maximum load that can be raised. Okay, so first thing I want us to recall that efficiency of a machine is given as mechanical advantage over velocity ratio times 100. So we are going to use the equation for mechanical advantage, that is, mechanical advantage is equal to load over effort. This will help us to determine the maximum load. But before we use this equation, let us first determine what the velocity ratio is. Now, velocity ratio is given as effort distance over load distance. Now, the effort distance is given as 2 pi r. Now, it is 2 pi r because when effort is applied to the lever arm to make one complete turn, then it traces a path whose circumference is 2 pi r. And then for the pitch, that is the distance the load is lifted when the lever arm makes one complete turn. So that when you're to calculate the velocity ratio of this machine, then doing our substitutions, we'll have on the numerator 2 pi r, where pi is 3.142, and the radius of that circular path is just the length of the lever arm, which is 0.4 meters. And then on the denominator, we have the distance the load is raised, which is the pitch, and the value is given as 0.005 meters. So that is what we have down here. And therefore, the velocity ratio will become 502.72 when this is worked out. Now with the velocity ratio, we can come back to this formula here and say efficiency. Remember, efficiency from the question we're given is 40%. So efficiency, which is 40%, is equal to mechanical advantage over the velocity ratio, and we have it as 502.72 right there, times 100. Now multiplying both sides by 502.72 over 100, we'll have mechanical advantage as 40 times 502.72 over 100, and that gives us 201.088 as the mechanical advantage. Now, with the mechanical advantage, we can come back to this point and say mechanical advantage is equal to load over effort. So that is what we have here. Mechanical advantage is 201.088. So right there. And then we equate that to the load over effort. Now the effort from the question we have as 25 newtons. From here, if we cross multiply, we'll have the load as 201.088 times 25, and that is 5027.2 newtons. Now that is for Roman 1. For Roman 2, we are told if the load is raised upwards at a constant speed of 0.2 meters per second, what is the power output of the jack? Okay, so power output is given as effort force times the distance over time. And from this equation here, we can see that distance over time, or rather displacement over time, this bit is equivalent to velocity, and therefore we can rewrite this equation here as power input is equal to effort force times velocity. Now the effort force we already have as 25, and The velocity we already given us 0.2 meters per second. And from this, we can therefore say effort 25 times velocity 0.2 is equal to 5 watts. Now that is the power input. Next, we know that efficiency of a machine is given as power output over power input times 100. And for our case, we already have the value of the power input. We already have what the efficiency of the machine is. Now, in order to find the power output, we make it the subject of this formula here. And therefore, the power output is equal to, that is efficiency over 100 times the power input. So we have efficiency, which is 40 over 100 times the power input, which we have as 5 watts. So we multiply by 5. And then finally, the power output becomes 2 watts. And that is how we go about this question. I want to thank you for staying with me to this end. Thank you for watching. Hope to see you in the next video. Bye.